Right now, over 10,000 airplanes are flying above you. Some are crossing paths. Some are closing in at over 1,000 miles per hour. And somehow, they don't collide. Not because the sky is empty, but because it's controlled. Hidden above us is a system of invisible highways, strict rules, and split-second decisions, all designed to prevent disaster. And if that system fails, even for a moment, the sky wouldn't just be crowded, it would be dangerous. Now picture this: two aircraft, thousands of feet above the ground, closing in on the same point in the sky. The pilots can't see each other. There are no road signs, no lanes, no traffic lights, just speed, altitude, and timing. And yet, every single day, millions of people trust this system without ever thinking about it. Welcome to Wonderscape, where we uncover the hidden systems quietly holding modern civilization together. And today, we're stepping into the sky to understand the invisible network that keeps thousands of aircraft from colliding every single day. The sky is not empty. From the ground, the sky looks calm, wide, open, empty. But that's an illusion. If you could see what's really happening, you'd never look at the sky the same way again. Aircraft are everywhere, climbing, descending, crossing paths, merging into invisible corridors at nearly the speed of sound. But here's the part most people don't realize. Without coordination, this system would collapse instantly. The real problem. Planes don't just fly, they share space, and that space is limited. Two aircraft closing toward each other can exceed 1,000 miles per hour combined. At that speed, there is no time to react. Which raises a question. How do thousands of aircraft move through the same sky without chaos? The system controlling the sky. The answer is air traffic control. But this is where it gets more complex than most people think. Air traffic control is not just people with headsets. It's a global system, radar, satellites, communication networks, all working together to keep aircraft separated. Controllers don't just watch planes, they predict them minutes ahead. They calculate speed, direction, climb rates, and conflicts that haven't happened yet. One simple instruction like, climb and maintain 36,000 feet, can prevent a conflict hundreds of miles away. Inside control rooms, there is no pause button. Controllers are tracking multiple aircraft at once, each moving at hundreds of miles per hour. A single miscalculation, even by a few seconds, can create a chain reaction across the sky. And here's the part that almost no one sees. They are constantly thinking ahead, visualizing where each aircraft will be minutes into the future, not where it is now. And the pressure is relentless, because every decision they make affects hundreds of lives in the air. But here's where it gets dangerous. Even this system has limits. When planes disappear over land, aircraft are tracked by radar. Controllers can see everything. But over the ocean, radar disappears, and for decades, so did the aircraft. Now imagine this. Planes crossing thousands of miles of ocean, completely out of sight. No real-time tracking, only position reports. Out there are no visual references, no cities, no lights, no landmarks, just endless ocean beneath the aircraft and thousands of miles between continents. Because once you're out there, there's no quick correction. Everything has to be right the first time. Pilots would check in at specific waypoints, reporting location, time, and altitude. Controllers use that information to estimate positions. Not exact, estimated. Which meant one thing. The system depended on precision. A system built on time. Over the ocean, separation isn't just distance, it's time. Aircraft might be spaced 10 minutes apart. At cruising speed, that's about 80 miles. But here's where things get risky. If one aircraft is early or late, it disrupts everything behind it. This is where things almost break. The modern breakthrough today, satellites have changed the game. Aircraft can now be tracked in near real time, even over the ocean. But here's what's surprising. The system didn't become loose. It became smarter. Take the North Atlantic track system. Every day, routes are redesigned based on wind, weather, and traffic. Temporary highways shifting across the ocean. But even with all this technology, aircraft still don't fly freely. The invisible highways, planes don't wander. They follow airways. Think of them as highways in the sky, not physical roads, but precise coordinates. Aircraft move from point to point across continents and oceans. These routes are not random. They are structured. Some go east, others go west. Altitudes are layered to separate direction. This creates order, but also density, and that density creates pressure. Why planes don't fly straight? Look at a flight map. Most routes are curved. That's not an error, it's efficiency. Planes follow great circle routes, the shortest path on a curved Earth, which means New York to Tokyo might arc north, and flights between Europe and North America bend toward Greenland. This saves time, fuel, and money. But it also creates something else. Congestion. The hidden risk. Some routes carry hundreds of aircraft per day. Major airports feed traffic into the sky non-stop, creating pressure on the system. So, airspace is divided into sectors, each monitored by a controller. As aircraft move, control is handed off, one sector to another like a relay race. But here's the question most people never ask. What happens if something goes wrong? When things go wrong, and sometimes things do go wrong, aircraft deviate from their path, weather forces sudden changes, communication delays happen. Now imagine multiple aircraft adjusting at the same time, each reacting to a different problem. This is where the system is tested, because it's not designed for perfect conditions. It's designed to survive imperfect ones. Layer after layer of protection activates. Controllers adjust routes. Pilots respond instantly. Systems monitor every movement. And most of the time, passengers never even realize how close the system came to needing those safeguards. The final safety net. There is one last layer, and it can override everything. It's called TCAS, the Traffic Collision Avoidance System. Every modern aircraft has it. It scans nearby aircraft constantly. If two planes get too close, it takes control. One climbs, the other descends immediately. When TCAS activates, there is no discussion, no hesitation. The system speaks, and pilots respond instantly. Because at that moment, speed matters more than explanation. Two aircraft, two decisions, perfectly coordinated in seconds. And if that system didn't exist, two aircraft colliding at cruising speed would release massive destructive force in seconds. It's one of the last lines of defense between order and collision. Pilots are trained to obey, even if it contradicts air traffic control. This is the final safety net because the system assumes one thing: failure is possible. A system that never stops moving. Unlike roads, the sky is dynamic. Routes change daily to avoid storms, turbulence, volcanic ash, and traffic. Some flights ride jet streams, others reroute hundreds of miles. Everything adjusts constantly. Millions of passengers think flying is routine. It isn't. It's controlled chaos. If the system failed. Now imagine this. No structure, no coordination, no invisible highways. Planes wouldn't spread out. They'd cluster, cross paths, conflict. The sky wouldn't just be busy, it would be dangerous, because the sky itself isn't safe. Final payoff. The system makes it safe. Every flight you see is part of a massive invisible network. Routes, controllers, satellites, machines, all working together every second, keeping thousands of aircraft apart. Without it, modern aviation wouldn't function. Global travel would slow, trade would suffer, and the sky above us would become unpredictable. Every time you board a plane, you are stepping into this system. You don't see it, you don't hear it, but it's working every second. quietly guiding thousands of aircraft through one of the most complex environments on Earth. And the most remarkable part? It works so well. Most people never even think about it. If this system fascinates you, subscribe to Wonderscape. Because the deeper you go into these hidden systems, the more unbelievable they become.